Section 7.3, Proving Triangles Similar. From our previous section, we know to prove polygons are similar, we have to show all corresponding angles are congruent and all corresponding sides are in proportion. In this section, we're going to identify shortcuts to this procedure. This is very similar to identifying shortcuts to congruent triangles. Our first shortcut is postulate 7.1. This is the angle-angle similarity postulate, and it's also abbreviated AA similarity. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Here, I'm given that angle E is congruent to angle B. I know that angle D is congruent to angle A. I also know that if two angles of one triangle are congruent to two angles of another triangle, the third angles are congruent. Therefore, all I need is the AA similarity postulate to prove that these two triangles are similar. But I also need a similarity statement, and that's very similar to the congruent statement. I have to line up my angles and sides and match them up with the angles and sides of the other triangle. So here, I'm going to start with triangle, and I'm going to start with the double arc E to the single arc D to no arc F, and state that that's similar to, and I'm going to do the same rotation in this triangle. I went double, single to nothing. I'm going to start with double, which is B, single, which is A, to nothing, which is C. Now what I have is the angles and the sides that match up. Angle E corresponds to angle B, angle D corresponds to angle A, and angle F corresponds to angle C. I also have the sides that can match up in proportion. So I can set up the ratios ED to BA is equal to DF to AC, which is equal to EF to BC. Our second shortcut is theorem 7.1, side-angle side similarity postulate, abbreviated SAS similarity. This theorem states if an angle of one triangle is congruent to an angle of a second triangle, and the sides including that angle are proportional, then the triangles are similar. So here I have angle B and E congruent, and angle B and E are included between side AB and BC and DE and EF. Therefore, this does generate my side angle side. Now, the only thing I need is to make sure that my sides are in proportion. And we can see that I go small to small, large to large. And when I do that, the smallest segment in ABC is going to match up with the smallest segment in DEF, which is 10/6. The next segment in BC that I know is 30. That's the largest one I know here. That matches up with the largest one in this triangle, which is EF. So 30/18. Now I just have to verify that this is a true statement, that this is equal to each other. I'm going to simplify the fractions. Here, I'm going to divide by 2 on both. That gives me 5/3. Here, I'm going to divide by 6 over both. That gives me 5/3. So it is true that my ratios are equal. That verifies that these two triangles are similar by the side angle side similarity postulate. Now I just have to set up a similarity statement. Triangle, and I'm going to start with A, B, C is similar to, and I started with the vertex that had the small segment, so I'll start with a vertex with the small segment, which will be D. Go to the congruent angle, E, and then F. And of course, on the previous slide, we demonstrated the angles match up and also the sides are in proportion. Our next shortcut is theorem 7.2, side-side-side similarity, abbreviated SSS similarity. The theorem states if corresponding sides of two triangles are proportional, then the triangles are similar. Here I have triangle A, B, C, and D, E, F. All that's known is the measures of the sides of each triangle. I need to determine, are the sides proportional, are the ratios equal? To do that, I'm going to set up the smallest segment in this triangle in a ratio compared to the smallest segment in this triangle, the medium side compared to the medium side, and the large to large, and see if the ratios are equal. Then, if they are, they're proportional, and the triangles would be similar by side, side, side similarity. So here I'm going to have small over small, 2 over 3, middle over middle, 4 over 6, and the largest, 5 over the largest, 7.5. This is 2/3 simplified. 4/6 is 2/3 when I simplify. And 5 over the improper fraction is going to give me 15 over 2, which gives me 5 divided by 15 over 2, or 5 times 2 over 15, which will be 10 over 15. And when I simplify 10 over 15, 5 goes into both. That gives me 2 over 3. Therefore, the sides are in proportion. That means that these two triangles are similar by the side, side, side similarity theorem. Now I just need a similarity statement. Therefore, triangle. I'm going to start with A, going from the smallest to the middle to the largest side, which is ABC, is similar to triangle, smallest to middle to large, DEF. Here's our first example. Are the triangles similar? If so, write a similarity statement and name the postulate or theorem used. If not, explain why. Here, I have two triangles. I have triangle ABE and ACD. ABE is 12, 21, and 9. And the large triangle, ACD, is 12 and 4 is 16. 21 and 7 is 28. And 12. Now I just set the sides in a proportion to determine if they are equal. Remember, small to small, large to large, medium to medium. So here, my smallest is 9. 9 over 12. Medium, 12 over 16. And large, 21 over 28. When I simplify, 3 into both gives me 3/4. 4 into both gives me 3/4. And 7 into both gives me 3/4. Therefore, my ratios are equal. They are proportional. And therefore, I know that these two triangles are similar. And they are similar by the side, side, side similarity theorem. My similarity statement is triangle. And I have it matched up here when I redrew them. ABE is similar to triangle ACD. On my next diagram, I'm given that two segments are parallel. ML is parallel to RQ. When that's true, I know if two parallel lines are cut by a transversal, then alternate interior angles are congruent. Therefore, angle L is congruent to angle R, and angle M is congruent to angle Q. I also could state that MPL, the angle, is congruent to the angle QPR by vertical angle theorem. But I already have two angles congruent, so I know that the triangles are similar by the AA similarity postulate. Now I need a similarity statement. Triangle, and I'm going to start with the single arc, go to the double, then to none. So I'm going to go LMP is similar to triangle. I went single, double to none. I'm going to go single, double, RQ, P. Again, we wanted to determine if these two triangles are similar. I know that Angle B and angle E are congruent. I need another set of angles. And to do that, I can state that angle ACB is congruent to angle DCE by the vertical angle theorem. Therefore, these two triangles are similar by the angle similarity postulate. Now I just set up a similarity statement. Triangle. I'm going to start with the 25-degree angle, 25 to the single arc to none. So I'm going to go BCA is similar, and I did 25 to single arc to none. I'm going to go 25 single arc to none, which is ECD. On my next diagram, I'm given triangle DEF and GHF. Here I know that I have two vertical angles and they are congruent. Therefore, I know angle DFE is congruent to angle GFH. I also know that these two segments, DE, is parallel to HG because alternate interior angles are congruent. So I also could get angle D congruent to angle G by the alternate interior angle theorem. But vertical angle theorems is easier. So I already have these two triangles similar by the AA similarity postulate. Now I just have to set up a similarity statement. Therefore, I have triangle, and I'll start with the non-marked angle, which is here D to the right angle E to F, so DEF is similar to, again, same pattern, GHF. On this diagram, I'm given triangle XYZ and triangle EGF. I know that I have congruent angles Y and G, and that angle on each diagram is included by XY and YZ, and here EG and GF. So this looks like I'm going to use the side angle side similarity postulate. So what I have to do is prove that these two ratios are going to be equal. So I'm going to go small to small, large to large. So here I have my small, which is 15, over the small here, which is 27, and determine if that's equal to 25 over 45. Simplifying both fractions, here I'm going to divide by 3. I'm going to get 5 over 9. And here I'm going to divide by 5 on both, which is going to give me 5 over 9. Therefore, those two sides are in proportion, and the angles are included. Therefore, these triangles are similar by the side angle side similarity theorem. Now a similarity statement, triangle, and I'm going to go from small side to the right angle to large side, XYZ is similar to triangle, remember small to right angle to large, so small, FGE. On my next diagram, I'm given triangle QRU. With side measures of QR being 12 and QU being 16. And that is set inside a bigger triangle, QST. And QS is equal to 12 plus 6, which is 18. And QT, which is 16 plus 10, which is 26. Here I have an angle, Q, that is set inside both of my triangles. So therefore, I can state angle Q is congruent to angle Q because of the reflexive property. So now if I take a look at these two diagrams, even though this one's inserted inside the other one, it looks like I'm going to use side angle side. Now I can just verify the proportions are equal. So small over small, which is going to give me 12 over 18. And determine if that's equal to large over large, which is 16 over 26. And when I simplify, here, 6 is going to go into both. I'm going to get 2/3. And on this one, I'm going to have 2 go into both, which is going to give me 8/13. And we can see that these are not equal. Therefore, the sides are not in proportion, and they do not meet the specifications of side angle side. So therefore, these are not similar triangles. Here I'm given a proof. I want to prove I have the ratio of AB over AC equal to BE over CD. I'm given that segment BE is parallel to segment CD. With that information, I can draw my arrows in my diagram. I know that I can then state that angle 1 is congruent to angle 2. And that's because of corresponding angles. Are congruent. If two parallel lines are cut by a transversal, then corresponding angles are congruent. I also can state that angle 3 is congruent to angle 4 for the same reason. I also could have stated angle A is in both triangles, therefore angle A is congruent to angle A by reflexive, but I already have two sets of angles congruent in each triangle. Therefore, I'm going to be able to state the triangle, and here I'm going to be able to match up the small triangle ABE is similar to triangle, and I went with A. A is in both, so A to single arc to C and to D. And those two triangles are similar by the A similarity postulate. Now, all I need to do is to write my ratio of corresponding sides. And here I have AB to AC is equal to BE to CD. And that reason is properties of similar triangles. I could also state definition of similar triangles. On my next proof, I'm given that segment AB is perpendicular to BC, therefore I know that angle B is a right angle. DE is perpendicular to EF, therefore that angle E is a right angle. And I can state now that angle B is congruent to angle E. They're both equal to 90 degrees, so definition of perpendicular lines. 3, I'm given that AB times EF equals DE times BC. If I divide both sides by EF and DE, what I end up with is a ratio of AB over DE equals BC over EF. And I can name that by properties of proportions. And when I look at my diagram, I realize that AB and DE and BC and EF make angle B and angle E included angles between those two proportional segments. Therefore, I can state that triangle ABC is similar to triangle DEF by the side angle side similarity theorem. Here, I want to state why the two triangles are similar, and I want to find the value of x. I know these two triangles are similar. Either I could state that this angle is in both triangles by the reflexive property, and I can also state that these two angles are congruent because if two parallel lines are cut by a transversal, corresponding angles are congruent. And also these two angles are congruent. Therefore, these two triangles are similar by the A similarity postulate. Now I just set up the two triangles. My two triangles being 8 and x, and my other triangle being 10 and 9. My scale factor is the ratio of two known corresponding sides, also known as the similarity ratio, 8 to 10. Simplifying, I get 4/5. Set up my proportion. 4/5 is equal to x over 9. 5x is equal to 36, and x is equal to 36 fifths. Again, I want to determine if these two triangles are similar and find x. I'm already given that these two angles are congruent. I know these two angles are congruent by the vertical angle theorem. Therefore, I know these triangles are similar by the AA similarity postulate. And what I'm going to do is realize that this triangle needs flipped over and reversed to match up. Therefore, I know that my scale factor is going to be compared to 15 and 9. And when I simplify, that's going to be 5/3. And 5/3 will set up my proportion for 21 over x. 5x equals 63. Divide by 5, and x is equal to 63 fifths.